All right, let's go ahead and start the formula and name writing part of the ionic and covalent naming. So we're given either a formula here or a name on the right hand side, and we're going to determine if it's a nonmetal and a nonmetal or a metal or a nonmetal. And with that information, we can determine whether it's ionic or covalent. And we're also going to find out if it has polyatomic ions because that helps us in our naming. So first, let's start with CaCl2. We know that Ca is a calcium element, so that's element number 20 on your periodic table, calcium. We have a chlorine right here, chlorine, Cl, so that's chlorine in the halogen group, element number 17, which is a nonmetal. So we're going to give it the metal and nonmetal. We're going to do a little check mark here. And we're going to say that it has no polyatomic ions because Cl is not a polyatomic ion. Now, we're going to ignore the section since it says that since we know that it's a metal and a nonmetal. And with this information, we know that this is ionic because a metal and a nonmetal go together. If it were covalent, it would be a nonmetal and a nonmetal. All right, so with this information, we can name it. So the first question we ask is it ionic or covalent? It's ionic. So we're going to follow the ionic naming rules. And the next question we ask is the first element, the metal, the cation, is the calcium a transition metal? If it is, we need to do Roman numerals in the parentheses. If not, we know the definite charge of calcium, which means that we do not need to put the Roman numerals in parentheses in the name. Now, in this case, calcium, element number 20, is not a transition metal, so we do not need Roman numerals. So our naming is just calcium chloride. Chloride. All right. Moving on to question 2. Now we're given the name, boron trifluoride. Now first, we once again determine the first element here. It's a nonmetal. The second element is automatically a nonmetal, so we go ahead and give that check mark there. And we know that fluoride, the fluorine atom, is not a polyatomic ion. And we know that based on this information here, it is covalent. So we start by writing, or we follow the covalent naming rules, and we start by writing the first one, boron, and we follow the trifluoride and put an F subscript 3. And that is your answer. All right, let's go ahead and move on to the third question. CuNO3. Cu, we identify it as copper, a transition metal. So go ahead and check that there. And we see the NO3, which is the nitrate polyatomic ion. So we're going to say, yes, it has polyatomic ions. And I'm just going to put that polyatomic ion there. And we know that since the first element there is a copper, which is a metal, a transition metal to be specific, it's ionic. With this information, we're going to go ahead and find the name. Since it's a transition metal, we do need to put the charge of the cation, in this case the copper, in parentheses. So we have nitrate, which is a 1- charge, and one singular copper atom, which means that the copper has to be a 1+ charge. All right, and that equals a net 0 charge, which we are all aiming for. Therefore, the name for this is copper, parentheses, 1 in Roman numerals, nitrate. And we keep the name, the ending name, in the periodic table. On the back of your periodic table, the polyatomic name stays the same. Let's take a look at number 4. We have ammonium oxide. And so ammonium, in this case, is our cation. So we know that it's a metal. It classifies as a metal. And we know that, therefore, it's ionic. And we know that oxide stands for oxygen, which is not a polyatomic ion. All right, so let's get to the formula. Ammonium is let's write that a little better. Ammonium is NH4 plus. Oxide, it has O, 2 minus. And so based on this, we know that there has to be 2 ammoniums for 1 oxide, because it only has a 1 plus charge, while the oxide has a 2 minus charge. With this information, our formula we can determine to be, let's write it a little better here, NH4, parentheses close, 2O. And that would be the formula for ammonium oxide. All right, next up, P2O5. So the first thing we do is identify. The first element here is a nonmetal. Give it a check there. And we know based on this information that it's covalent. And we look at the oxygen here and determine that we have no polyatomic ions. For the name, let's take a look at the phosphorus, P2O5. So we have not a 1, but 2. So we have to do diphosphorus. Remember that we do not put the mono in front of the first element if it's only 1. Diphosphorus pentoxide. All right, and that would be the name for P2O5. All right, infinite more problems to go. Let's find out. Next one, PbO2, lead. So we have first one here, lead, which means that it's the metal. It's a metal that we're putting. So based on this information, we can give the metal box here a check. And we know it's ionic. And we know oxide is not polyatomic. And we know that based on this information, we do have to put the charge for lead because it can hold multiple charges. So we would go ahead and put lead. And since we have 2 oxygens with each a negative charge of 2, 2 times 2 is 4. Since there's only 1 lead, it's going to be a 4 plus charge it holds. So the lead parentheses IV. Let's write that IV a little. Jesus Christ. IV a little better. Lead 4. And then the oxide. Remember, that stays the same. All right, let's pick the pace up a little. Al2O3. We know Al stands for aluminum. Aluminum is a metal, which means it is indeed ionic. Oxide, once again, is not a polyatomic ion. And so Al2O3, we consider that the oxygen's charge is 2 minus times 3, which is 6. 2 minus times 3 is 6. And divided by the amount of aluminums, there it is, 2. So each aluminum holds a 3 plus charge. 3 plus charge. So based on this information, we know that this is indeed a net zero charge. But in this case, aluminum has a given charge, which is in the boron group of the periodic table. So we do not need to put the parentheses. So instead, we will just write aluminum oxide. Alrighty. Next up, we have xenon octafluoride. So we know fluoride, which is the fluorine atom, is not a polyatomic ion, and indeed a non-metal covalent compound here. Based on this, we know there's only 1 xenon, so our formula will be xenon, Xe, and F as in 8, because octa stands for 8. And we have 8 of the fluorides and the xenon. So the next one, let's take a look. We have SO2. We know that sulfur is a nonmetal, which means it has a covalent type naming. And oxygen, oxide, is not a polyatomic ion. And so taking a look at SO2, we're going to write sulfur because we do not put mono in front of a single cation element or anion element up front. So the first anion, the S, we do not put anything, any suffixes or prefixes on that. So it's just sulfur. And since we have 2 oxygens, we're just going to put dioxide. And that's it. Next up, we have beryllium carbonate. So beryllium, Be, element number 4, is a metal. That's an alkaline earth metal. And we have carbonate, CO3 2-, which is indeed a polyatomic ion. And you can find this, of course, on the back of your periodic table that you're given. And because of this, we know it's a metal-nonmetal bond with an ionic. All right, let's come up with the name. Beryllium, of course, an alkaline earth metal, has a 2+ charge in nature, while the carbonate ion has a 2- charge. Therefore, one of each suffices to balance it out, and therefore your final formula is BeCO, let's write that a little smaller, BeCO3, and that is your answer. All right, let's take a look at 11. CO2. I hope everyone knows what CO2 is, but of course, if you don't know, you don't know. It's carbon dioxide. But let's come up with the actual formula for it. So CO2, we determined that carbon, a non-metal. So let's give that box a little check here and write covalent. Of course, oxide is not a polyatomic ion. And the name for this is carbon, since the first element or first atom up front doesn't get any suffixes or prefixes, it's just what it is. And oxide, carbon dioxide, because there's 2 oxygens and the suffix for that is di. All right, number 12, lithium phosphate. As we all know, lithium, a group 1 alkali metal, has a 1+ charge, and phosphate, if you look on the back of your periodic table, is PO4 3-. So with this information, we know that it is indeed a metal-nonmetal bond representing an ionic relationship with a polyatomic ion of PO4 3-. With this information, we know that we need 3 lithiums totaling a 3+ charge to cancel out that -3 on the phosphate. So our equation or formula here will be lithium Li3PO4. And make sure to watch that capitalization because oxygen is a separate atom. Next up, we have Cu3PO4 2. We all know that PO4 now, because of the previous question, is indeed a polyatomic ion. And that means that copper up front is indeed a metal, ionic. And let's write the name for this. Copper is a transition metal, so we do need parentheses and the Roman numeral for the charge of it. And let's figure out the charge. PO4 has a 3- charge overall times 2, which is 6. Divided by 3, because there's 3 coppers. Each copper will have a net charge. So each copper, not the total, each copper will have a charge of 2+. Let's write that, 2+. So with this information, we can do copper, parentheses, Roman numerals 2, and then phosphate. Phosphate. Remember that it stays identical to what is found on the back of your periodic table. Question 14 asks about carbon monoxide. We know that's carbon, a nonmetal, so we give the little checkbox here. Monoxide, the root word of that is oxide, which means oxygen. There's no polyatomic ion here. And because of the nonmetal bonding, we know that it is covalent, represented by that C. With this information, we can go on and move on to the formula, and let's figure it out. So carbon, there's nothing in front of it, so we know there's only 1 carbon. Monoxide, mono meaning 1, means we only have 1 oxygen. Therefore, our formula is simply CO. Next up, number 15, AuO, which is AU. AU is found on your periodic table as element number 79, and that is gold. Sorry about that, gold. AU is gold. So AU, a transition metal, and everyone knows gold is a metal. So we give that little checkbox here. I for ionic, since it's a metal and a non-metal. And we know that there's no polyatomic ions because it is simply oxygen. So with this information, with this information, we can figure out the charge of Au because oxygen has a 2- charge. And in order for this whole thing to equal 0, the gold has to be a 2+ charge. So the way we write this is gold 2 oxide. All right, and then let's move on to 16. Tungsten oxide, tungsten 3 oxide. We know that based on this parentheses, tungsten is a transition metal. And strangely enough, tungsten does not have a T in its formula name. It's instead it's W as in number 74 on your periodic table. And so that since each tungsten has a 3+ charge, as indicated by the parentheses, we know that each oxygen also has a 2- charge. In order to balance this out, we need 2 tungstens totaling a 6+ charge and 3 oxygens totaling a 6- charge. So we need 2 tungstens and 3 oxygens. All right, with this information, oh, we forgot to fill this part out. All right, so tungsten, a transition metal, mark that here. Oxygen, oxide, no polyatomic ions, and we know it's ionic. So with this information, we can figure out the formula, which is W2O3. Let's move on to the second page of the worksheet. All right, very simple. There's only 1, 2, 3, 4, 5, 6, 7, 8 left. All right. And let's go a little faster on these since we probably got the hang of it with the first million there were. All right. Au, once again, we know that's gold, so it's a metal, non-metal. So give it a checkbox here. Oxygen is not a polyatomic ion. And we know based on this information here, it is ionic. So gold, Au, is marked by a 2- charge on oxygen divided by 2 because there's 2 gold molecules, which means each gold has 1+ charge. So it would be gold, parentheses, Roman numeral 1, oxide. All right, next one, lithium oxide. We know oxygen has a 2- charge, lithium has a 1+ charge. For every 2- charges, we need 2 lithiums to balance it out. Therefore, our little equation here, or formula here, would be lithium 2 oxygen, so Li2O. We know that it is ionic because lithium is an alkali metal in group 1 of your periodic table. Go ahead and put I and select the metal non-metal section there. And we know obviously oxygen is not a polyatomic ion. SBr6. So sulfur and bromine. So sulfur is indeed a non-metal, so give it a checkbox here. Br simply is just an element. It is not a polyatomic ion. And we know that it is a covalent relationship here because of the non-metal present in SBr6. With this information, we can name this by saying sulfur. First element stays exactly how it is, no suffixes or prefixes. And then we could do a bromine. So the bromine is characterized by a 6, which is hexa. So hexabromine, bromide. All right. Next up, number 20, vanadium nitrate. Vanadium is element V on your periodic table. That is a transition metal. That's number 23. And each nitrate, NO3 minus, we know vanadium has a 2+ charge. So we can go ahead and answer this by saying it is indeed a metal non-metal and ionic. And the polyatomic ion here is nitrate, NO3 1 minus. For vanadium here, we could say that for every 1 vanadium ion or atom with a 2+ charge, we have 2 nitrate polyatomic ions with 1 minus charges each. So if you have 2, it would equal 2 minus, and that would match the 2 plus charge on vanadium, canceling it to 0. So then we would do V parentheses NO3 2, because that indicates that the whole polyatomic ion gets a 2, not just the oxygen at the end. Alright, NCl3, nitrogen and chlorine. So nitrogen is indeed a nonmetal, which means it is a covalent relationship, and the Cl alone indicates that it is not a polyatomic ion. With this information, we can start by using the covalent naming mechanism and go ahead and say nitrogen. First one stays identical, and then trichloride. Alrighty. Next up, copper 2 nitride. Remember the IDE ending, meaning that it's just the nitrogen, nothing else attached to it. So we know that nitride is a 3 minus. That looks like a 2. 3 minus. And copper has a 2 plus charge in this scenario. Now, if we have 2 nitrides, we only need 3 coppers. So we only need 3x copper and 2x nitride. So x here is times, 2 times nitride. And we know that copper here is a transition metal, hence the Roman numerals in the parentheses. Go ahead and select metal, non-metal here, and it would be ionic. And nitride, while it sounds like it, is indeed not a polyatomic ion. With this information earlier, we can determine the formula to be copper Cu3, nitride N2. Alright, so next one up, my favorite formula to do these naming things on, CCl4. It sticks to the tongue, and it's one of the easiest to remember. Let's determine whether it has a metal or non-metal up front, which is a carbon. Carbon is indeed a non-metal, so go ahead and select that. No polyatomic ions, since just the chlorine here. And it would be under a covalent relationship. So with this, we have C, just put the name of it, nothing else done to it, no suffixes, prefixes, carbon. And we have 4 chlorines, which is chlorides. And 4, as you all know, the suffix for that is tetra. Tetrachloride. So CCl4 would be carbon tetrachloride. Alright, let's go ahead and finish it off strong with selenium diiodide. Wow, what a mouthful to say. Selenium is indeed found as element number 34 under 2 under oxygen with a charge of 2 minus. I'm sorry, we don't actually need the charge, we just need the symbol. And we know that diiodide here, di meaning 2, is iodine. Based on this information, we know immediately that it is under a covalent relationship due to both atoms here being a non-metal. Go ahead and check that off. We know iodide just means iodine. Wow, so creative. So which means it has no polyatomic ions. Therefore, the formula for this is selenium diiodide, meaning 2. So SeI2. And that's it.